Good evening, sir. Good evening, all. Am I audible to you?
Yes, sir.
Good evening, sir.
Sir.
Good evening, sir.
Good evening, sir.
Okay, let's start the class. Okay, already late.
Sir, which chapter, sir?
Yeah. Yeah, yesterday's lessons continuation. Structure of chamfer. First, you know the structure of chamfer. Later, we are going to discuss the structural elucidation of chamfer. Right. Then first you come to what is the structure of chamfer? This is the structure. This is also
Sir, which block, sir?
my voice is breaking.
Which block, sir? Chapter name, please.
It is the last block, natural products. In the natural products, I think second unit.
Okay, sir. Okay, sir. Thank you.
Now this is the camphor. The structure of camphor. It is a monoterpene, a terpenoid, sorry, monoterpenoid. And it is a crystalline solid. Melting point 180 degrees centigrade. And occurrence that is isolated from the source. It occurs as a plus active isomer and a minus active isomer and as a racemic mixture. That is, it occurs as a plus camphor and minus camphor. These two are enantiomers. And plus or minus and equal portions. It is a racemic mixture. It is a racemic mixture, right? Whenever we are coming to isolation, the plus camphor, that is 1R, the two chiral centers are there, 1R, 4R, camphor. It is isolated from the camphor tree. Its botanical name is Cinnamon camphora. This is the botanical name. It is generally appeared in Japan. Formosa, Iceland. Formosa, Iceland. Now, when you're coming to the minus isomer, it is minus camphor. It's exact reverse because it is a enantiomer to the above one. It is 4S camphor. It is the oil of not matrica, matricaria, Parthenium. there anyone botany specialist? You can identify this name, right? These are the sources for the camphor. Next, what are the uses of camphor? It is used in perfumes, and medicines. It is the ancient medicine. Okay, and also in the chemistry, especially it is a general use. Whenever we are coming to chemistry, it is used as a resolving agent. Resolving agent and a chiral auxiliary. In asymmetric synthesis. What is the asymmetric synthesis of chiral compounds? Is known as asymmetric synthesis, right? Next, coming to structure determination. This is the fundamental information about the camphor. Now coming to the structure elucidation or structure determination. Structure elucidation. First one, when we coming to the first point is always molecular formula. That is C10 H16O. It is the molecular formula. And based on the physical properties, it is optically active. It is optically active. Therefore, it is existing with at least one chiral center. One chiral center, right? Now, coming to second point, camphor it is with C10 H16O. Is treating with NH2OH. That is hydroxyl amine hydrogen chloride. This is the NH2OH HCl, right? Now, what's happening whenever this hydroxylamine hydrogen chloride reacts with camphor, it leads to formation of camphor oxime. Camphor oxime. This camphor oxime indicates the presence of one carbonyl group. This, whatever it may be, the hydroxylamine, suppose you take any compound is existing with aldehyde or ketone, these are known as carbonyl compounds. Carbonyl compound are treating with hydroxylamine hydrogen chloride. That leads to formation of R C double bond O N OH. This is aldoxine. Or if it is a ketone, the ketone generates a ketoxine. This is the aldoxine.
అసలు కనిపిస్తలేదు.
కనిపిస్తుందా? Okay. Yes, now it is okay.
Okay, sir.
Right.
మీరు ఒకటి తీసేస్తాడు అప్పుడే.
It is ketoxine. It is aldoxine. It is ketoxine. Now, this is the general information only. All these reactions are covered in BSc second year level. Okay. And
ల్యాప్టాప్ లో పెద్దగా వస్తుందా ఇది? ఇందులో అస్సలు ఒక ముక్క అక్షరం కనిపిస్తలేదు నాకు. హైడ్రో ఇది ఏంది?
right. The formation of ketoxine. What is the molecular formula? This ketoxine is existing with a ketone or any carbonyl compound. Then the camphor enzyme is generated, that is C10 H16 NH OH. Actually NH there is no H here, simply OH. In the place of oxygen, that NOH will be replaced. NOH will be replaced. Then, therefore, it indicates that this reaction indicates the presence of carbonyl group. Presence of carbonyl group. Now coming to the third one. Camphor, molecular formula C10 H16O, treating with HNO3. Right? It is nitric acid. Whenever it is treating with nitric acid, actually this is act as a mild oxidizing agent. Therefore, the camphor is converting into camphoric acid. Its molecular formula C10 H16O4. Here, the camphoric acid structure is also unknown. Camphoric acid structure is also unknown. But whenever it is treating with a sodium hydroxide or potassium hydroxide, it produces disodium salt or dipotassium salt of camphoric salt is generated. Camphoric acid salt is generated. From this reaction, we can conclude that, or it indicates that camphoric acid is a dioic acid. Camphoric acid is a dioic acid. Now look at here. Due to the presence of the ketone group, look at here. This is the ketone. For example, R prime. Whenever it is treating with HNO3 or any oxidizing.
Please down, sir.
Yes.
Please down.
Hello.
Please down, sir.
Right.
Okay.
Whenever it is treating with HNO3, therefore it is undergoing oxidation that leads to the formation of a carboxylic acid with two different carbons, two carboxylic acids. Right. Suppose if it is aldehyde, it is treated with the same reagent. It is only produces monocarboxylic acid. Whenever it is ketone, there is acyclic ketone. This is acyclic ketone. This acyclic ketone is treated with HNO3 that leads to the formation of two carboxylic acids, a mixture of two carboxylic acids. But at the same time, the aldehyde is treating with the same HNO3 that leads to the formation of only monocarboxylic acid. Right? Suppose if you take any cyclic ketone, cyclic ketone means I am taking the ketone like this, right? You take the CH2 and N. Now this is the cyclic ketone, a general cyclic ketone. It is also treating with HNO3 oxidation that leads to formation of dioic acid. That means the carbonyl group is a ketone. This reaction indicates that the carbonyl group is a ketone. That ketone is the cyclic ketone. Again, I am repeating, if the carbonyl group is an aldehyde, it gives monocarboxylic acid. Okay, if it is a acyclic ketone, that leads to the formation of a mixture of carboxylic acids. But our product is dicarboxylic acid, dioic acid. That is the dioic acid or dicarboxylic acid. The formation of dicarboxylic acid or dioic acid is the only way is if the ketone is existing as a cyclic ketone. If it is an acyclic ketone, it leads to the formation of a mixture of carboxylic acid, but that is not happening in this reaction. Therefore, the camphor is not giving any mixture of carboxylic acid, but it giving only dioic acid. The formation of dioic acid indicates that the ketone is existing in the form of a cyclic ketone. From that, you can write that. Therefore, from the above reaction, it indicates that, or it infers that the carbonyl group is a ketone and it is cyclic ketone. Right. Next, fourth reaction. The fourth point or fourth reaction. In this nature of C double bond O. Already 80% is confirmed the nature, but again some reaction. The camphor, sorry, list of nature you call it as environment or surroundings of C double bond O, or simply call it as environment of C double bond O group. Now here the camphor is treating with HNO3, HNO2, nitrous acid now. In previous case, we are reaction is conducted with the nitric acid, but in this case, we are using nitrous acid. This nitrous acid leads to the formation of camphor oxime. This camphor oxime is a ketoxide. Ketone plus an oxime. Ketoxide. It is not ketoxide. It is a ketoxide. When this ketoxime generation takes place, look at it. Suppose this is the ketone is existing with an alpha carbon with alpha hydrogen. Alpha carbon with hydrogen. That is, the alpha position is SCH2 carbon is there. Whenever it is treating with HNO2, nitrous acid, that leads to the formation of ketoxime. The ketoxime is generated. Therefore, the formation of ketoxime only possible when keto group must have alpha saturated carbon is in the form of CH2. Right? This reaction indicates the formation of ketoxime is only possible when ketone must have alpha saturated carbon is in the form in the CH2 form. Right? Then only it can form the ketoxime. Next, coming to nature of ring. Nature of ring or rings. Yeah. The molecular formula of camphor. It is C10H16O. Right. Now, this is here the oxygen valency is 2. That means this is equivalent to 2 hydrogen. Then with the fully saturated molecular formula C10H18. C10H18. It resembles to CnH2n minus 2. CnH2n minus 2. Because here oxygen is divalent. Oxygen is divalent. Now, after the acquiring this general formula, we have some conclusions from nomenclature. From nomenclature, we already know that Cn, already this is discussed in yesterday, is the monocyclic. CnH2n minus 2 bicyclic system, ring system. Right. CnH2n minus 4 tricyclic system. Right. Now, what is the formula here? Cn H2n minus 2. Therefore, it indicates that from the molecular formula of camphor, indicates it is a bicyclic system. Bicyclic. Now coming to nature of ring. Fifth point. Nature of ring. Term in camphor. Right. Here, camphor, you take the camphor with the molecular formula C10H16O, is treating with zinc chloride or zinc distillation, or instead of zinc, you can also take the phosphorus pentachloride. Then it leads to formation of a known structure. It is already generated in the alpha terpene or laminin isolation structure determination, that is parathymine. Parathymine. From that, we can write that formation of parathymine indicates that camphor is having one 6-membered ring. The formation of parathymine indicates that one 6-membered ring is present in the camphor, because from the previous step, in the previous point, from the molecular formula, camphor indicates it is a bicyclic system. Molecular formula of camphor, it indicates it is a bicyclic system, right? In the bicyclic system, one of the ring system is there. Therefore, 2 rings are there. In the two rings, one of the ring system is 6-membered ring. That we have identified with this reaction. Zinc chloride or phosphorus pentachloride is treated with camphor, that leads to formation of parathymine. The formation of parathymine indicates that camphor is having one 6-membered ring. And another maybe it is the bicyclic ring. There is a second ring, maybe a 5-membered ring or 4-membered ring or 3-membered ring. Right? How it is, you can identify later in the later steps. Right? First, you write the conclusion step here. Formation of parathymine indicates that camphor is having one 6-membered ring. Camphor is having one 6-membered ring, and the second ring may be 5-membered or 4-membered or 3-membered ring. It will be identified later, right? Now coming to next one, 7th one, camphor is C10H16O is treated with is distillation with iodine. You mix the iodine to the compound, just add the iodine and distill it. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . distillation. Right? Now, what's happening? It generates a new compound. It is already known compound. That is, it is a parasamine derivative. That is hydroxyparasamine. You call it as, or a common name is there. That is carvacrol. Name is carvacrol, or also called as hydroxy 3-hydroxy parasamine. This product is generated. Right. What is the indication? In the new compound, there is a in group OH group is present. That OH group indicates that OH group is generated from the keto group which is present in the camphor. The carvacrol OH group is the carvacrol OH is due to the presence of keto group in the camphor. And second point, the OH is adjacent to the methyl group instead of isopropyl group. This also indicates that the keto group is adjacent to the methyl group, not the isopropyl group. These two facts are revealed from this reaction. Therefore, we can write the conclusion here. In carvacrol, where carvacrol OH in carvacrol OH group is adjacent to methyl group. Therefore, the keto group also must be adjacent to methyl group or alpha position to the methyl group. In the camphor. It is not the adjacent to the isopropyl group, and it is also reveals that the same reaction also reveals that the saturated CH2 group, that is the alpha position to the keto group, right? The alpha position CH2 is the reason for the formation of ketoxane. The ketoxane is due to the presence of a alpha CH2 group. That alpha CH2 is adjacent to the isopropyl group, not the adjacent to the methyl group. A single reaction reveals the three factors. That is presence of keto group, and second, the position of keto group is alpha to the methyl group, and third fact, the CH2, saturated CH2 group is present alpha position to the isopropylic position. Right? Then this is also you need to write. In camphor, alpha saturated CH2 group is adjacent to isopropyl group, or it is sandwiched between keto group and the position which isopropyl group attached. This is the isopropyl group attached position. This is the keto position. This CH2 group is sandwiched between this keto group and the position, the isopropyl group attached position. Right? These three facts are revealed by this reaction. Right? Next. The structure of camphoric acid. Here the camphoric acid is generated. What is where the camphoric acid is generated? We can hear. Yes, this is the camphoric acid. Whenever we are treating this is the camphoric acid. Camphor is treating with the HNO3 that leads to the formation of camphoric acid. First, you need to determine the structure of camphoric acid. Coming. 8 points. Structure of camphoric acid. Structure of camphoric acid. What is the molecular formula of camphoric acid? It is the dioic acid. You are already known, right? The point A. The molecular formula is C10H16O4. This is the molecular formula, right? From this molecular formula, coming to the molecular formula, the C10H16O4, it is existing in two acid functional groups, that is dioic acid. Therefore, CH14COOH taken twice. This is the dioic acid, right? This dioic acid both are treated as from two hydrogens. Now, fully saturated structure, that is C8H16. C8H16. Now, this is resembles to CnH2n. From this molecular formula, I have given the list of types of cyclic system: monocyclic, bicyclic, tricyclic. General formulas are given. From that, what is that? This is indicates the monocyclic.
Octane.
Yes, my monocyclic system. Therefore, indicates that camphoric acid is a monocyclic compound. But here it is not possible to know the ring size because it is having 8 carbons. 8 carbons. In the previous case, we are generating the parathymine with the camphor by using a zinc chloride and phosphorus pentachloride, or carvicrol from the distillation by mixing the iodine. In both the case, we can identify the 6-member ring. In the bicyclic system, one ring is 6-member ring. That may be the second ring may be the lower than the 6-member. Once the 6-member ring is identified, that may be a larger ring. The next second ring may be a lower member ring. Due to that reason, I'm in previous case at that point, the fourth, maybe at 6th point, we have given that a assumption. The second ring may be a 5-member ring or 4-member ring or 3-member ring, not more than the 6-member ring. Then here, the number of carbons are 8 carbons are there. Therefore, we cannot reveal the or we cannot find out the size of the ring of the which is present in the camphoric acid. Then further we are applying some other experiments. Now coming to C, camphoric acid. The camphoric acid is an oxidation. It's an oxidation with any oxidizing agent like chromic oxide with H2SO4, right? Or K2Cr2O7 solution. Okay, potassium dichromate solution. Then this camphoric acid is converting into camphonic acid, camphoronic acid. It is converting into camphoronic acid. This camphoronic acid having a molecular formula C9H14O6 along with one carbon dioxide molecule is liberated. Carbon dioxide molecule is liberated. Now, this camphoronic acid is treated with sodium hydroxide in quantitative manner. It is the trisodium salt of camphoronic. This is the camphoric acid. Camphoric acid. This is the camphoronic acid. Is generated. Camphoronic acid salt is generated. Therefore, the trisodium salt means it indicates that this is a tricarboxylic acid. Is a tricarboxylic acid. Trioic acid or tricarboxylic acid. Now, another experiment. In another experiment, you take the camphoric acid. Camphoric acid. In the atmospheric distillation. Atmospheric distillation that leads to the formation of a mixture of products. In that mixture of products, it leads to the formation of two equivalents of or two molecules of, you can take it, two molecules of isobutyric acid. Isobutyric acid. Two molecules of isobutyric acid along with trimethyl succinic acid. Trimethyl succinic acid. Trimethyl succinic acid and two molecules of carbon dioxide and one molecule of or one equivalent of elemental carbon. This is the two equivalents. This is the one equivalent. This is two equivalent, and this is one equivalent. Then, first you coming to the isobutyric acid. What is the structure of isobutyric acid? This is the isobutyric acid. Right. Succinic acid. Trimethyl succinic acid. Trimethyl succinic acid. What is the trimethyl succinic acid? This is the succinic acid. COOH. COOH. This is a succinic acid. All the hydrogens are there. Okay. Now the three hydrogens are replaced with three methyl groups. This is known as trimethyl succinic acid. Along with this, it is generated two equivalents. It is generated one equivalent, and two carbon dioxides are generated. Two equivalents of carbon dioxides are generated, and one equivalent of carbon is generated. Now, later studies, the trimethylsuccinic acid, predict, it is a scientist, suggests that camphoric acid is a alpha beta trimethyl carboxylic acid. Here I am going to write. A British scientist, according to his work, British suggests that camphoric acid is a camphoronic acid is a alpha beta trimethyl carboxylic acid. Trimethyl carboxylic acid. Now, what is the structure from his suggestion? The structure of camphoronic acid is COOH, CH2, COOH, CH3, CH3, COOH. This is the structure of camphoronic acid. Structure of camphoronic acid. Now, by using this structure, by using his suggestion, we can explain the formation of isobutyric acid and trimethylsuccinic acid. Right? How this isobutyric acid, 2 equivalents of isobutyric acid, 1 equivalent of trimethylsuccinic acid, and 2 equivalents of carbon dioxide, and 1 equivalent of elemental carbon. Generation can be explained by taking this structure. In this degradation, 2 equivalents of camphoronic acid is involved in the degradation reaction. In this degradation reaction, 2 equivalents of camphoronic acid is involved. Now I am going to take 2 equivalents of camphoronic acid. It is important degradation. Please listen carefully. This is one molecule and another molecule. CH3, COOH, CH2, COOH, CH3, COOH. This is the another molecule of camphoronic. Now, simple distillation at atmosphere. In atmosphere. Okay. Now, what's happening? Look at here. In this molecule, first the breaking of this bond, carbon-carbon bond. Right. Okay. Now it leads to the decarboxylation. 1 carbon dioxide is released from this position. What's happening in this one? CH3, COOH. CH3, COOH. Therefore, 2 molecules of isobutyric acid is generated. 2 molecules of isobutyric acid is generated. Look it here. Again, I am repeating. This bond will be broken down. This bond is broken down. Right? From this decarboxylation reaction takes place. Therefore, this hydrogen is taken by this carbon. It is generated as CH3, 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 COH. And carbon, it requires one hydrogen bond. How it is occurred, I will tell you later. Therefore, the two fragments are generated. What are the two fragments? Yes, CH3 plus say CH3, CH3, COH. Right? Next. Again, it undergoes in the second molecule, it undergoes decarboxylation first. It undergoes decarboxylation. That means here one CO2 is generated. Here another CO2 is generated. Two carbon dioxides are released. Two carbon dioxides are released. After releasing, therefore it is generating CH3 actually. Again, this bond will be broken down. This bond will be broken down. Now, after generation, we get here. This bond and this bond will be generated. That means this hydrogen, whatever the hydrogen is leaved here after decarboxylation, this directly attached by taken by this carbon only. Now this leads to the formation of trimethyl COH, CH3, CH3. Now here this one is there. What is that? CH2. In the CH2 group, it releases the raw carbon. The two hydrogens are here. One of the hydrogen is received by this carbon, and another hydrogen is received by this hydrogen. Therefore, the two equivalents of isobutyric acid. Two equivalents of isobutyric acid, one equivalent of trimethyl succinic acid, and two equivalents of carbon dioxide, one equivalent of carbon is generated by consuming two equivalents of camphoronic acid in the atmospheric degradation or distillation. Therefore, this the structure of whatever the Bredick suggested the structure alpha beta trimethyl carboxylic acid structure is the structure of camphoronic acid is confirmed. Right? We can write the conclusion here. Therefore, camphor is bicyclic. The camphoric acid is monocyclic, and camphoronic acid is acyclic. We get here. Camphor is the bicyclic. Camphoric acid is the monocyclic. Camphoronic acid is the acyclic. Therefore, the three methyl groups on the camphoronic acid as it originally present in the camphor. These are not affected by the oxidation. Actually, any methyl group are not affected by the degrading reagents. Therefore, whatever the methyl groups present in the succinic acid, trimethyl succinic acid, just a minute, that's the problem. Yeah. In this, one methyl group and two methyl. Total three methyl groups are there. These three methyl groups are actually originally these three methyl groups present in the camphor. These are not affected by any oxidizing reaction, oxidizing reagent. That is the another fact. The three methyl groups on camphor and camphoronic acid as is originally present in the camphor. Present in the camphor. These are not affected by oxidizing agents or oxidation reactions. Right. Therefore, now we know the structure of camphoronic acid. Based on the camphoronic acid structure, we need to determine the camphoric acid structure. Size of the monocyclic ring in the camphoric acid. Next, coming to the 9th point, size of monocyclic ring of camphoric acid. Size of monocyclic ring of camphoric acid. Now, what is the molecular formula? C10 camphoric acid molecular formula. H16O4. Yeah. It is a dioic acid. C8 H14 COOH taken twice. Now these are the monovalent equivalent to 2 hydrogens, therefore it will be converted into C8 H16. That C8 H16 is CN H2N. That indicates the monocyclic. In that monocyclic, coming to again C8 H16. In the 3 methyl groups are there. That is C5 and 9 carbon, 9 hydrogens. 3 into 3, 9 hydrogens. That means H7 CH3 taken twice. These 3 methyl groups are originally present in the camphor. Therefore, the size of the ring is 5-membered ring. The size of the ring is, therefore, it may be 5-membered ring. Maybe 5-membered ring. Then, now the camphoric acid is a 5-membered ring with 2 carbonyl groups and 3 methyl substitutes. Look at here. Camphoric acid is a 5-membered ring with 2 carboxylic groups. That is the dioic acid. 2 carboxylic acid groups and 3 methyl substitutes. From this, camphoric acid is a 5-membered ring with 2 carboxylic acids acid groups and 3 methyl groups. 3 methyl groups. By this, again the Bredict suggested. Bredict suggests the structure of camphoric acid is this is one methyl group, this is another methyl group, and the third methyl group is here. Right, and here a hydrogen is there. The formation of camphoric acid from camphoronic acid from camphoric acid. This is the camphoric acid. By assuming this structure, the Bredict suggests the structure of camphoronic acid actually. But how the camphoronic acid is generated from the camphoric acid is explained like this. This is the structure of camphoric acid. Right. He applied the oxidation on this camphoric acid. Then it leads to the formation of first initially a hydroxy compound is generated. This hydroxy compound undergoes the decarboxylation. The decarboxylation takes place from this position. That leads to the formation of hydrogen, COOH, and CH. Again, it is subject to oxidation. Again, it is subject to oxidation. During the oxidation, this sigma bond will be broken down. That sigma bond is broken down. That leads to the formation of CH3, COOH, COOH. Right. These two methyl groups are as it is. Then again, it is also due to the formation of a tricarboxylic acid. This is the tricarboxylic acid. There is intermediate generated first. During this oxidation, first just okay. Yeah. One of the intermediate keto intermediate generated. How it is first it will be generated. Yes, this keto product is generated. Once the keto product is generated, again it is subject to the further over oxidation. Then it leads to breakage of this bond. Right. This is the tricarboxylic acid. This is camphoronic acid. Right. Now, when you coming to take the camphoric acid structure, an intermediate is taken in the next step. Then reaction. Camphoric acid, which is subjected to heating, then it leads to the formation of camphoric anhydride. Camphoric
Down, sir.
anhydride. Camphoric anhydride. What is the camphoric anhydride? Later I will see you. Then this camphoric anhydride is treated with the bromine in phosphorus, raw phosphorus. Then it leads to formation of monobromo camphoric anhydride is generated. Camphoric anhydride is generated. Then, what are the conclusions from this? Suppose camphor is the bicyclic, right? Here, whenever the camphoric acid is heating, it eliminates the water molecule. That leads to the formation of camphoric anhydride. You know the camphoric acid structure. What is the camphoric acid structure? This is the camphoric acid structure. COH. Yes. Whenever we are heating, there is a elimination of water from this. That leads to the formation of the 7-membered ring will be generated. This is the anhydride. Now, at the alpha position of for this carbonyl, anhydride carbonyl is there, the C double bond O group. At the alpha position, it is substituted with the methyl group. But at the second one, this is another C double bond group. At the alpha position, one hydrogen is there. Whenever it is treated with bromine in presence of phosphorus, this hydrogen is replaced with the bromine. Hydrogen is replaced with the bromine. Okay. Now, this reaction indicates that at the one of the alpha position of the two anhydric carbonyl group having the one alpha hydrogen. That is the reason for the formation of bromo product. Sorry, here it is bromo. This is the bromo product. Okay. From that, all these conclusions. In the previous point, we already know that camphor A bicyclic system. In the bicyclic system, one of them is 6-membered ring. These are the facts we are revealed from the experiment. Okay, the second one is, another one is 5-membered ring. And second point, keto group adjacent to the methyl group. Keto group is adjacent to the methyl group, and CH2 group is alpha position to keto group. And adjacent to isopropyl group.
ఇప్పుడు నువ్వు వెళ్తావు బయటికి అని నేను ఖచ్చితంగా చెప్తున్నా.
Adjacent to isopropyl group. And these are the facts we are identified. Okay, from all the above evidences, the structure of camphor can be proposed in the two possible structures. From all the above facts, above facts or evidences, the structure of camphor is written as in two possible structures. The first one is this is structure A. And this is a structure B. Structure A and structure B. Next, which one is satisfying from previous observation? Look at here. The first one is 6-member ring and 5-member ring. This is the 6-member ring, and another one is 5-member ring. Okay. Then keto group is adjacent to the methyl group. In the keto group is not the adjacent, it is the beta position. It is alpha and beta. And in the structure A, the keto group is alpha position to the methyl group, right? Therefore, the structure A is more probable structure. The structure A is the most probable structure for the camphor, not the structure B. From the above structures, structure A is satisfying the all the above conditions. Therefore, the structure A is the camphor structure, and it is finally confirmed by its synthesis. Okay. After synthesizing and obtaining the material, that camphor material, then compare it with its original. Okay. Take the synthesis from your book. I don't want to explain all those reactions. If you have any doubt, you can ask me. Today you read it. If you have any doubt, you can ask me. I will explain. Right. Now I am going to conclude the session. If you have any doubt, you can ask. This is the structural illustration of camphor.
Sir, by degradation method and this method are same.
Where you are asking degradation method?
Structure of camphor for using degradation method and this method will be same.
This is different, na?
Okay, sir.
Yeah, it entailed from this step 2. What is that? Yeah, we are starting at point 1. Molecular formula of camphor 2 at this point, last point. This entire thing is the structural illustration of camphor. Okay, to elucidate the structure of camphor, we need to elucidate the structure of camphoric acid and camphoronic acid. Then only we arrive to the final structure of camphor. After suggesting the structure of camphor, that is the structure A, finally we need to confirm by
last line.
Yes.
What is written in last line, sir?
From the above structures, structure A is the satisfying all the above conditions. Therefore, the structure A is the camphor structure, and it is finally confirmed by its synthesis. Yeah. So this terpenoids lesson is over. Tomorrow I'm going to explain alkaloids. Unit 17. Unit 17 is also bigger one, almost 35 pages less than that one. Okay. Tomorrow it may be definitions and classification, general isolation of alkaloids, and structural isolation, general methods of structural isolation of alkaloids. Later we move to the structural isolation of quinine, structural isolation of epaverin. This is the unit of alkaloids. It is also 2 to 3 classes lesson. Let's see how much we will complete. We can complete. Okay. Any others?
Hello.
Yeah.
Okay, sir. Thank you, sir.
Sir, if may ask 5 marks question, the entire thing will be write everything.
Camphor structural illustration will not ask it in 5 marks question. It will be appeared in the long answer question. If suppose if it is asking for the 5 marks question, they may ask the structural illustration of camphoric acid or camphoronic acid only, or otherwise synthesis of camphor. These things may be appeared in the short answer questions, but in the always long answer question appear like write the structure determination of camphor, like that.
Okay. Okay, sir.
Anything?
Nothing else.
Thank you. Someone is speaking. Speak loudly. Yeah, okay. I'm closing the session.